Water is such a natural thing for us, and we maybe don't question where water comes from and how much of it is available. We are naturally surrounded by water. We use water every day in our households, at our work, in industry. However, a large part of it is not even visible for us. Water vapor in the atmosphere, a result of evapotranspiration, which is the water being transported from the land surface to the atmosphere. My name is Julian Koch. I work at the Department of Hydrology at the Geological Survey of Denmark and Greenland. We work with hydrological modeling, investigating the hydrological cycle. As hydrologists, we cannot measure everything everywhere. We need hydrological models that help us integrate all available observations. We use hydrological models to understand the hydrological system, but we can also use these models to make predictions of the future and to assess how climate change or land use change affects the water resources. I'm currently working on a project called All-Wet, that stands for All-Weather Evapotranspiration. In this project we work on satellite-based estimates of evapotranspiration. With traditional thermal-based estimations, satellites cannot look through clouds. However, in this project we teamed up with researchers from NASA and US Department of Agriculture, who have developed a microwave-based land surface temperature dataset that is much more tolerant to cloud and thereby can give us an all-weather estimation of evapotranspiration. For a specific case, we have set up a hydrological model for the Senegal Basin in West Africa. Since the early 2000s, there has been a greening of the Senegalese Sahel area, mainly due to the growing of trees. However, in the last few years, there have been severe tree die-offs. If we look at the Senegal Basin, which is partly tropical, subtropical basin, we can see that traditional thermal-based observations are very limited. Especially in the rainy season, we often only get a handful of observations based on thermal satellites. And if we look at microwave-based evapotranspiration data, we can see that the coverage increases up to 80% or more. So there's a clear benefit of using microwave-based evapotranspiration in such areas of the world that are highly affected by cloud cover. It's clear that climate change is impacting the hydrological cycle. We observe hydrological extremes getting more and more extreme and more frequent. And I would say that sustainable use of water as a resource is a key challenge for future generations.